So welcome to the, the digital twins being covered quite a bit in in our overall forum this year. I'm going to focus, the intent or the focus of this session is going to be the digital twin in the manufacturing setting, which is a pretty broad term, and it doesn't really indicate any particular one industry, as long as they're making something, and they're manufacturing something in a product or an asset or service or both together. So let me just kind of jump right in here and get going. So what I'm going to do, could we go back for just a second to introduce? I just wanted to go, yeah. So. Other than I'm representing ARC, my name's Dick Stansky, and I'm a senior analyst at ARC, and I'm covering this area of the digital twin along with the whole PLM engineering and design tools area for quite a few years. So today we have two companies, Kimberly-Clark and Eastman Chemical. And Kimberly-Clark is sponsored by BrainCube in terms of solutions and so forth in this area of digital twin implementation. And Eastman Chemical is sponsored by Siemens. So we'll start, I'll start and give a little overview of the topic, and I think this suffices as for an introduction. So let me jump right in here. Whoops. There we go. So I put this in the context of smart manufacturing because smart manufacturing is an overall umbrella of technologies in a lot of different areas that's really changing the face of manufacturing. And manufacturing probably in the next decade is going to be like, the changes is going to be nothing like we've seen. I mean, if you just take the automotive industry making the major sea change over to electric vehicles, it's going to change manufacturing for them. It'll be comparable to what Henry Ford did when he introduced the assembly line back in the early part of the 20th century. But at any rate, so let me. There are, I think, what I would call several emerging technologies that are driving this smart manufacturing, not the least of which is the digital twin and the implementation of that. So we have the notion of the Internet of Things, industrial Internet of Things, connected assets, everything's connected, production systems, physical products, virtual design, everything is that the prerequisite for any of this stuff to work is everything's got to be connected. Another area is the intelligent edge, where we are truly having intelligence, and it's one of the game changers, and I'll talk about that a little bit later. But it's really one of the game changers in terms of getting the right kind of data, and for these systems and the machines and the assets to actually use inferencing engines at the chip level for prescriptive and self-healing, and it's a real game changer. So it's going to the robust data from that layer, and of course we have big data analytics, machine learning, operational intelligence. These are all descriptors of various solutions that kind of drive this whole notion of the smart manufacturing environment. We're seeing really advanced automation systems today. I think, other than the idea of advanced robotics has moved to the point where a robot now can work in conjunction with the human worker. You don't have to put the robot in the cage anymore. It become quite advanced, and this is due to AI and cognitive processes and so forth in that area. Cyber physical systems and so on. It's all a part of this. An area that is really next generation material science. We're not even going to go anywhere near that on this today, but it's one of these things that's really changing the face of what the products, the manufactured products are made out of today. And then of course things like additive manufacturing, generative design. It's really changing the face of things. Okay, here we go. Whoops. Why doesn't it? There we go. Just quickly, I just want to go over this. What is the definition? The definition of the digital twin has been bantered around for quite a while. It all depends on what knothole you're looking through, what industry and what use cases and so forth, really for the most part. But there have been kind of I think a general industry consensus has emerged. And basically, from a discrete manufacturing perspective, you can look at it as an as-built, as-designed, as-maintained physical product or production process or equipment, assets, which is augmented by actual simulation models. So you have to have two parts of this. You have to have the virtual side in the virtual models, and you have to have the real-time operational data for any digital twin to actually emerge. And bear in mind that a digital twin doesn't really exist until you actually produce the product, the asset, the system, the physical system. Then and only then do you start to really build a digital twin. And just to throw another thing in here, the Digital Twin Consortium, which is a consortium of a fair amount of, I think, a good representation of suppliers and users, where they have an interesting definition. Digital twin is a virtual representation of real-world entities and processes and synchronized at specific frequency and fidelity. And then you can break each one of those down. Boy, this thing's tricky. There we go. Kind of a Venn diagram perspective of this. I look at the virtual and physical system relationships. You have virtual systems merging with the physical systems, and you get these cyber physical systems kind of in the middle, and then you get things like embedded edge intelligence and industrial IoT. But on the virtual side, you get the actual virtual models, the virtual simulation, and all this is also related to the whole engineering area of CAE, the traditional engineering test applications like finite element analysis and computational fluid dynamics and stress analysis and all that kind of stuff. It's been around for a long time, but it's all now a part of the digital twin. So implementing a digital twin is essentially, I think, and from my perspective, is essentially an exercise in an IT and OT integration at a fundamental level. So how is the digital twin being implemented today? Well, one of the first areas that was kind of glommed onto is by companies, especially those companies with a lot of expensive assets, especially in the process industries, is maintenance equipment in the field. And you see things like maintenance technicians using augmented reality and so forth as a part of that. The intelligent edge and smart devices and sensors and AI-enabled products and equipment. This is an essential component of today's digital twin, and that's how it's essential to this implementation. Operational simulation. What it really comes down to, we want to simulate what the operations are doing so we can enhance the performance, but we have to have real operational configuration data. Virtual commissioning, which is an area that's been around for a while, maybe a decade or more, and I think that where virtual commissioning is a one-shot, static time commissioning or validation of a system using virtual emulation, where the digital twin is a real-time, continuous process, a closed loop, if you will, process. And then, of course, cyber physical systems, real-time simulation modeling, and so forth. So some of the roles of the digital twin in smart manufacturing. Digital twins are used throughout the production lifecycle to simulate, predict, optimize the product, the production systems, and so on before developing physical prototypes. The whole notion of the physical prototype is, well, I don't know if it's totally gone, but we do that using the virtual modeling now. So the basic concept of the digital twin is not particularly new. It's been around for a decade or more. Dr. Greaves and some of his peers developed that some time ago. But the advancement of the technologies and the advancement of the emerging technologies has really driven the implementation of that. And then using digital twins of the product and production processes, they can overall reduce the assembly, installation, and validation of the production system, which is one of the functions of virtual commissions, actually. One thing that we found out going forward in this is that manufacturers really need to focus on the operational digital twin, if you will. Yeah, making sure that their as-built and their as-maintained configuration of the physical product is as accurate and detailed as possible. In other words, it's the old adage of the more accurate your actual configuration is, down to the minutia of the system, every torque value, every pressure, every bit of the vibration that you want to monitor in the system, so that you can maintain it, improve it, and so on. And what we're also finding out is that the digital twin, having a digital twin that actually works, and from the perspective of of the concepts, really can enhance the supply chains. I mean, it's the whole thing about moving things through the system at a faster rate. And in virtual simulations of factories and the production systems and entire plants really is an integral component. The design, build, operate, maintain lifecycle is connected by a digital thread, and you probably all heard that term, which is very essential. Essentially, the digital thread is the digital twin's an operational implementation of the digital thread. So some of the challenges and obstacles that we've seen arise, 75% of companies are already implemented or looking at implementing some form of IoT, and they want to implement some form of digital twin. They just have to figure out what their use cases are, what their value proposition is, and how does it fit into their processes, and what's the payoff. Again, companies need to provide the exact individual configuration of the product or the asset. That's really important. We're finding that companies haven't made it past the pilot stage. Many companies at this stage haven't made it past the pilot stage and really aren't using it to scale, but that's changing rapidly. And as I mentioned before, a CAD model or a virtual simulation or a BOM, bill of materials, is not a digital twin. That's still back in the virtual world. A digital twin doesn't exist. A digital twin is created when the manufacturing of the product is complete. And successful implementations are basically based on understanding exactly what technologies are required to collect the right operational data for your process, your factory, and your plant. For a digital twin analytics operational performance to be effective, the context of the product or the asset or the system is required. The physical configuration is defining the physical configuration is just as important or more important than the actual virtual model itself. The landscape, I won't spend a lot of time on this. This is sort of the cloud edge landscape in terms of an architecture. You've got the enterprise cloud over on the right, it's infrastructure as a service and so forth. And then you have the edge computing layer, if you will. You're looking at things like private cloud servers, advanced control analytics, and so forth, and the gateways. It's platform as a service. You're seeing the emergence of that because the solution providers are looking at the digital twin as an architecture, and that's an important concept for companies that want to implement it. You have to develop an architecture. And then over to the far edge is where the money, where the rubber meets the road, so to speak. You see that one line there of this is you got data moving around at maybe plus microseconds, 500 above, and then when you get down into you get down into the far edge, and you get down into the control systems, and so forth. it's really it's hard real time. It's nothing new here. This is what any old control engineer's been dealing with for a long, long time. You can't have latency in the system when you're moving robots and things around, so forth. So architecting an intelligent industrial IoT systems, what the point of this whole slide here is that companies are going to have to take that architecture seriously. Along with, it's not just a matter of having some models, some virtual models, and being able to define your configuration, but you have to understand what you're trying to do from an architectural perspective, because that also helps you define what your resources are and what you can really do. It'll have to be an integral part of it, of doing this. And many companies are currently defining and implementing, that are trying to do a digital transformation. They haven't even progressed yet to define the tiered architecture, which has been one of the basic components of a vertical architecture, say from control systems moving up to the enterprise. And we've been dealing with that. Whoops. Yeah, we've been dealing with that. So these digital twin builder platforms are really emerging right now. There's some really good technologies out there. Companies need to explore what's available and look at the technology and who's got the most competent solution that makes the most sense to your processes. So that's basically it for me.